100 trillion is a really, really big number. It's so big that it is hard for us to establish any type of perspective. For example, if you measured the distance to the moon in millimeters, 100 trillion millimeters would be 125 round trips to the moon. Yeah, it's a really big number. Did you know that ferroelectric memories, or FRAMs, can be written and erased over 100 trillion times? That's remarkable. Or that FRAM doesn't include any ferrous material despite its name. Yeah, me either. So stick around to learn more from the industry leader in FRAM technology.
On today's edition of Tech Chat, sponsored by Mouser Electronics, we are joined by Shavindra Singh, Lead Principal Applications Engineer at Infineon Technologies. He's going to be educating us about ferroelectric memory, also known as FRAM. We're going to learn about trends in the memory markets, how FRAM works, its key characteristics and performance advantages, and its use in some example applications. So I would encourage you to stick around for what promises to be a very helpful conversation. Shavindra, welcome to Tech Chat.
Thank you, Dell and Mouser team, for my introduction and organizing this session. I am delighted to introduce you about Infineon's random access memory product as well as a special coverage on EXCELON-FM. So thank you again.
Great to have you here. So before we dig into FRAM, can you give us some background on Infineon's random access memory solutions?
Sure. Infineon holds the memory leadership for over 35 years, which is based on three strong pillars. The comprehensive product portfolio. As you know, that Infineon acquired Cypress Semiconductor in April 2020, which broadened its product catalog and able to offer complete system solution built with MCUs, memories, connectivity, power MOSFET, and so on. And Infineon memory leadership, in fact, came in via Cypress Semiconductor acquisition. And the second pillar for our 35 years of memory leadership is coming through the assured quality and reliability. And because we are in a leadership position in automotive and industrial application, we follow a rigorous quality checks and maintain very high industry standard for every product we design at Infineon. And not only that, Infineon is a reliable supplier whom customers can trust because of our commitment on product longevity, which usually runs over 10 years. And I am proud to say that we have many customers even today whom we have been supporting for over 15 years, and I'm very confident that we will continue doing it for many more years. And the last but not least, best in class technical support by enabling a broad ecosystem engagement, enablement tools, and collateral. Infineon has a very strong developer community with more than 34,000 members actively engaged with this community. So all this shows our leadership in the memory for over 35 years.
Yeah, that Infineon acquisition of Cypress not even 2 years ago was a pretty major acquisition between two major players in this space. And it's obviously been a huge success. I wish I'd been smart enough to invest in Infineon back then because the valuation has doubled in less than 2 years. So congratulations on that.
Thank you.
So after 35 years of work in the memory space, how is Infineon positioned today and where are you investing for the future?
So Infineon memory solution is number one in NOR, which is primarily used for program memory, volatile RAM, which is primarily used for the expansion RAM, and non-volatile RAM or NVRAM for critical data logging use cases. And as you see, Infineon offers widespread product categories with best-in-class performance advantage for each of them, and they are quantified into the metric column on the slide. So this summarizes why Infineon memory number one, because it offers a broad portfolio of high-performance memories for embedded solutions.
And we're going to be talking primarily about the FRAM today, but it's really good to see where that technology fits into your overall portfolio. Some of these spaces, you don't have very many competitors. Why is that?
So the FRAM technology as such is a very niche in terms of providing the features, and I'm going to cover a little bit in the later slides. However, just at a high level summary, the FRAM technology enables a very high endurance cycle and non-volatile at bus speed. On top of that, it offers extremely low power performance, which makes it very competitive and suitable for the battery operated system where the reliability as well as the power performance matters a lot.
So as a world leader in these memory technologies, can you shed some light on the important trends you are seeing in the market?
Sure. So let's talk about the trend in embedded system, which drives the memory requirement for future. And Infineon, as a company, we are closely monitoring that trend to bring that some of those trend requirement into our next generation product definition. So, for example, automotive. The changing regulations mandate EDR or event data recording for vehicle safety and research purposes. In the medical domain, continuous collection of clinically relevant patient data for accurate and reliable diagnostics, and industrial evolving industry 4.0 infrastructure demanding increased sensing and processing at the edge and generating more data. So this specific trend tries to drive the high density data logging need, and we are consistently increasing the density for our non-volatile data logging memories. So I can sum up here that Infineon closely monitors and understands industry trends and accordingly drives the memory requirement, which is whether it's a high density, fast write, no data loss, or a serial interface, high performance serial interface, and also the package, which is primarily driven by the industrial and small form factor systems. And on top of it, the power optimization is one of the key driving factor for some of the battery operated system. So I can say Infineon continues to upgrade the product features such that it can meet not only the current industrial trends but always targeted to comparatively meet the next generation embedded application requirements.
Yeah, well, that's a real tough challenge there for your engineers. You want more density, faster write, and lower current. Those don't usually go together, so that's quite a challenge.
That is correct. Yes. So meeting all the attributes in one design is the challenge, but we have a way to overcome it. So I will little bit talking more about that in the later part of the presentation.
That sounds great. I'm looking forward to it.
So Infineon RAM product is broadly divided into two memory types. The first type is the volatile expansion RAM, which is essentially used to expand the on-chip memory, whether it's ASIC or MCU, and provide the same performance by supporting through the external memory. And we have quite a few products into that, which are primarily the fast asynchronous SRAM, synchronous SRAM, as well as the hyper RAM. The second memory type, which is a non-volatile data logging memory for storing the extremely critical and sensitive data, which systems cannot afford to lose. And few example of non-critical data logging can be logging the current state of robotic arm in industrial automation. So think about there is industrial automation and there are multiple robots doing different functionality. And in case if there is a power outage or glitch, some of these robots needs to restart, and in that case the halfway through the progress of industrial any setup has to be disregarded. So to protect that, all every robot arm in the automation are basically equipped with the battery backed up or non-volatile RAM type of technology, so that any moment or any state change is recorded in the real time. Similarly, in the front-end camera buffer in autonomous ADAS or ladder logic in PLC. So these are the few examples of the critical data logging in industrial space. And as you can see, Infineon supports a broad portfolio of these memory types with a wide density range and high performance serial and parallel interfaces, with write and read performance going up to 400 megabytes or 3.2 gigabits per second.
Yeah, real-time storage is not something we typically think about with regard to non-volatile memory. The write times tend to be pretty long.
Exactly. Yes. Here we are summarizing the global leadership position in RAM solution, and Infineon will continue to hold the memory leadership and maintain its number one position in FRAM, SRAM, and NVSRAM, which are designed into high performance and highly reliable industrial, automotive, defense, and medical applications. And Infineon memory users are not only widely spread across major application segments, but also in different regions across the globe. So Infineon is committed to deliver high performance non-volatile RAM solution with consistent focus on high growth markets such as industrial, automotive, medical, and defense through continuous innovation. These NVRAM solutions will primarily be developed using Infineon's FRAM technology, and I will be covering about it during next few minutes. I will also discuss Infineon's next generation EXCELON-FRAM products and its key attributes, which will help you to choose the most suitable data logging memory for your applications.
Well, that sounds great. Now I'm really kind of excited here to get technical with you and dig into FRAM and understand it a little more.
Sure. So let's talk a little bit about the FRAM as a technology and the mechanism behind this special memory type. So FRAM is a type of non-volatile memory which uses ferrocapacitor made of lead zirconate titanate to store the data, and the PZT is the kind of the crystal, the structure. So FRAM holds the characteristic of random access memory with non-volatility, which makes it FRAM non-volatile write and read symmetrical, which means if you are accessing the memory at say 100 megahertz, you can write at 100 megahertz and read from the memory at 100 megahertz and without any overhead or impact on the write speed. So as you can see in the two crystal diagrams on this page, FRAM data state is represented by the orientation of dipole in PZT crystal. The dipole orientation determines the logic state in FRAM. For example, if up polarization represent data 1, then opposite of it or down polarization represent data 0. And as you see from the electric field versus polarization curve on the right hand side, if the positive electric field is applied, it changes the dipole orientation to plus PR, and the polarization state remains in plus PR state until the electric field is applied in opposite direction to change it to minus PR. So if you remove the electric field, the current state remain as is, either at plus PR or minus PR, and it does not change. So this property is actually tapped to build the non-volatile FRAM memories. And since EP characteristic of PGT resembles the hysteresis loop of a ferromaterial, hence the ferro name is used in FRAM nomenclature. While in reality, there is no iron component in FRAM, therefore it is completely immune to magnetic field environment. So as we understand the functionality of FRAM memory technology or the characteristic of FRAM memory technology, these characteristics offer several key advantages in FRAM, such as no delay write. Since you are changing the dipole orientation in an electric field environment, there is no movement of charge or any tunneling. Therefore, the write happens instantly. High endurance. These characteristics can support up to 100 trillions of write or read operations because there is no tunneling and therefore there is no wear out mechanism in this technology. Energy efficiency, as there is no tunneling or there is no like high voltage requirement to move the charge from one node to another, the no charge tunneling, unlike floating gate memory types such as E2PROM flash are involved, and this makes FRAM highly energy efficient during write operation. So for example, let's say if you have to write say 16 byte of information into FRAM, it can take X amount of energy, and if you want to transfer the same amount of data into E2PROM, it will take 200x compared to FRAM, and if you are transferring the same amount of data in flash, it can go up to 3000x energy. So that is the advantage, and it can offer such kind of energy efficiency through FRAM. And the last but not least, the polarization is through the dipole, and therefore it does not contain any charge or movement or quantum of charge, and therefore it is completely immune from any energy radiation such as alpha, beta, or gamma.
So did I hear you correctly? The ferroelectric RAM, despite its name, is not a ferrous material at all.
That is correct. It has a zero component of ferrous material in it.
That's fascinating. I've been hearing about ferroelectric materials for a decade probably, and I never heard that. So that's an interesting data point you shared with us. Are you expecting, Shavendra, that FRAM is likely to replace double EEPROM in most applications going forward?
So we have been seeing this trend wherever there is basically, as we have discussed, that EEPROM having endurance and the power problems, and wherever there is a demand for optimize those performance, definitely FRAM is going as a direct replacement on EEPROM on the same socket with the same set of opcodes and better performance. So yes.
So on a previous slide, you said that FRAM is optimized for low-power data logging. That really caught my eye. So what is it about FRAM that makes it so well-suited for these applications?
Okay, so let me try to explain with an example. Let us consider a typical use case with several sensors which generate stream of critical data that need to be captured instantly in a non-volatile memory to prevent system downtime and facilitate predictive maintenance. There are two ways to implement the solution: using EEPROM or flash with power backup. Since EEPROM and flash are slow programming memories with limited write endurance, they cannot be used directly for storing the stream of data on the fly. In this case, incoming data stream is first written into system's volatile buffer in a circular fashion And if any critical system events such as power fluctuation or hard reset or even system shutdown triggers, the host controller transmits data to each programmer flash using backup out. Therefore, in this case, data integrity and data reliability depends solely on the external components that significantly poses data at risk in mission critical systems. This is the type of use case where Infineon and VRAM provide significant value add by not only simplifying the system architecture and reduction in components, but protecting the last moment mission critical data under all odd circumstances. Since FRAM non-volatile write throughput is identical to SRAM with extremely high endurance count, system can implement the circular buffer in the non-volatile FRAM directly and eliminates every scenario which can pose data at risk. 100 trillion endurance translates to FRAM cell continuously exercising write and read operation at 40 MHz for over 35 years. So let us say the system is not using FRAM 100% time at its speed but only 50% time at 50% rated speed, say 20 MHz. In that case, FRAM cell will survive more than 140 years, which way higher than any system's end of life.
That's excellent. So we've talked about the different types of memory that Infineon supports, but even within the FRAM technology space, you have multiple product families available, correct?
That is correct. So this slide shows about the FRAM transition from the standard serial FRAM to the EXCELON family FRAM. So standard serial FRAM was basically came to Infineon through the acquisition of Ramtron International Company, and through which acquisition we got the standard serial I2C and SPI part, but they were like limited to SPI only or serial only the devices. Excelon FRAM was built using the same FRAM technology with optimized architecture to meet the basically the different industrial or automotive or the low power segment requirement, and that's why we've find out three different flavors into Excelon family. Excelon LP, which is designed with the energy efficiency and the inrush current control features. Battery powered medical wearable and implantable are one of the key uses, basically the one of the key application use case using the Excelon LP devices. Excelon Auto is basically automotive grade 1 ACQ 100 qualified part, going up to 125 C ambient temperature, and this is primarily used into the high reliability automotive application, including automotive ADAS system or airbag, telematics, as well as tachograph for the critical data logging. Similarly, Exelon Ultra is designed for performance and reliability, and they are also available in a very small form factor. So one trend which we are seeing currently in industrial design is moving from parallel interface to the serial interface, and the primary reason is to save the IO count. And as you can see, in a parallel interface device, it can count up to 40 IOs to interface with the host controller system, and that is a lot of IOs in nowadays because of the shrinking form factor of the ASICs or MCUs. So everything is moving from serial to parallel to serial, and even though this transition is happening quite fast, but the requirement for the system performance or the data throughput is not changing, which means the serial has to be designed such that it can meet the parallel performance, and we are enabled to basically we are able to enable that successfully through the Exelon Ultra design by adding a quad SPI interface at running at 108 megahertz, which essentially gives 432 megabits of data transfer over the quad SPI bus, and it meets all the like widely adopted industrial applications such as PLC, CNC, circuit breaker, or gaming machine, and in fact one of the evolving field is the industrial IoT.
Yeah, that seems like a great solution for a lot of different applications, and it's interesting that you're seeing the trend to go from parallel to serial. I've seen in the industry on the NAND flash that they're going from serial to quad and octal SPI things. So it's funny how the markets go in different directions for different applications, but for you guys trying to really pack that density in and a small form factor, it's pretty impressive that you can get those kind of data throughputs on a serial interface.
That is correct. Okay, so this summarizes why Exelon is great fit for data logging application, and also fits to BOM of all critical data logging needs because of a few key attributes which we have designed into the Exelon family product. instant non-volatility, which allows capture data immediately in data logging application, reliability due to 100 trillion endurance and 100 plus years of data retention, and then the functional safety, which makes it ASIL B compliance for automotive. And also we are seeing some of the growing demand of functional safety use cases in the industrial application. So this is one of the key feature we have introduced by adding a CRC or the ECC like feature in the EXCELON family product. And high performance is coming through the quad SPI running at 108 megahertz, which essentially gives the data throughput of 432 megabits per second. And that data you can write into the non-volatile directly, which is a significant leap compared to any alternate memory technology. Let's say if you have to transfer the same data into EEPROM flash, it will take like 10x to 20x more time to save that information into these memories. So it makes FRAM as one of the critical component in industrial data logging use cases. And the last but not least, the architecture. So Excelon, we have re-architected the Excelon family product and made it such that scalability of the product becomes basically very minimal time to market. And this is helping us to keep a pace with the new demand or new market requirement, and we are able to design in those very quickly and reduce the time to market very significantly.
So you mentioned here that broad product portfolio with your flexible architecture. Can we take a look at that portfolio in some more detail?
Sure. So as you see here, we have like three category of product: Excelon Auto, Excelon Ultra, and Excelon LP. And if you see the timeline or their availability, all except 16 megabit quad SPI automotive E-grade part are available in production status, which means you can buy them today and start using into your the final application. And Exelon Automotive offers up to 125C grade 1 fully ACQ 100 qualified and in small form factor. Basically, we are supporting our standard small form factor such as 8-pin SOIC, or even some are available in 24 VGA package options. Similarly, Exelon Ultra, it offers extended industrial temperature range, which can go up to 105C. So we are not only supporting 85C standard industrial, but also in the extended temperature range. And this is coming up as a rapidly growing demand in primarily in the PLC sorts of application where the high temperature need is arising. And again, not only the wide temperature range, but we are also supporting a very small form factor like 10 square 8 GQFN package, in addition to supporting industry standard other packages like 8-pin SOICP, DFN, or 24 BGA. So to summarize here, what we're saying that we are not only offering the standard package option, but also we are trying to minimize the size of the package such that it fits some of the form factor constraint end systems, and they are also coming a lot in demand. And again, Exelon LP offers the extended industrial temperature range, and in that same 10 square 8-pin GQFN, and as well as other small form factor industry standard. So today we have a portfolio which meets or suits a different application requirement, and they are all available into the production status.
Yeah, that's a broad product portfolio there. I'm taking it from the CY part numbers, that those come from the Cypress part of the merger?
That is correct.
Are you seeing any particular, where are you going next, I guess, if you can give us headway? Is it more memory? Is it lower power? What are you seeing from the demand, and if you, without giving away secrets?
So we are seeing the demand both ends. Yes, we are seeing the demand for the higher density, and some of the medical wearables, they are demanding for the higher density for storing more and more data logging, because some of the diagnostic demanding for the more data capture, and that is basically increasing the need for the density. And similar thing in the PLC application use case, where the number of IOs in the PLCs are increasing, and that is demanding more. So yeah, we are seeing a lot of demand towards the higher density, and we are working on it. At the same time, yeah, the low power, the miniature system, battery operated system, they are driving towards the power efficient parts.
That makes perfect sense.
Yeah.
So how do these products then stack up against your competitors?
So as you can see here, we have just summarizes our product features against a few competitor devices. And as you see, most of the places we are able to mark check, basically meet or exceed the competition. And that is primarily because of the architecture. We optimize the architecture, and we are able to bring the three flavors of the product, meeting the three different market requirements. So wherever there is a need for the high data throughput requirement, we are able to achieve that with the same architecture. Wherever there is a need for the low power mode, we are able to successfully achieve that, and basically provide the right feature part to our end customers.
That's pretty remarkable there that, anytime you can double the performance on a particular spec, that's usually pretty outstanding progress. But here you're like 10x on multiple specs where you're better than the competition.
Yes, and that is another the improvement we did in the Exelon architecture, and we introduced some of the really low power modes such as hibernate, standby, and active current. Also optimize the active current such that it really meets the power performance and optimize for the battery operated system. So yes, you're right.
Yeah, that's exciting. We're seeing here that the automotive electronics market is just really hot with the massive expansion in EVs and autonomous driving, expanded infotainment. So you've mentioned your products for automotive. So tell us a little bit more about that.
Sure. We have quite a few design in and design win activities in automotive. Let me give you an example of event data regarding in ADAS or advanced driver assistance systems. So ADAS systems facilitate improved safety with better driving experience. As vehicles become more autonomous, there is an urgent need for highly reliable event data record in these systems to ensure lost event capture. Having reliable last moment pre-crash data is vital for accident reconstruction as well as vehicle safety research. So as you notice in the architecture block diagram, FRAM is connected to the MCU where mission critical data is continuously received and logged in real time on the fly. Prior to the introduction of FRAM in these systems, alternate solution used to use volatile RAM with battery backup option. Since the data integrity and reliability was fully dependent on external power backup, it was always a challenge for the system designer to secure an uninterrupted power supply, especially during a car crash, to secure pre-crash data. Exelon FRAM eliminates all these challenges due to fast non-volatile write with virtually unlimited endurance while providing fully automotive qualified part, supporting up to automotive grade 1 at 125C.
Yeah, that's one of the most demanding applications where you need to do continuous, instantaneous writing at high reliability for a decade. It's an impressive solution that you guys are bringing to the market.
Yeah, so 17 is another like the use case example, programmable logic controller, which is primarily used for the industrial control and industrial automation. And what it does is use the FRAM or any non-volatile RAM memory solution to store the runtime state of IOs as well as system configuration data. And this continuous real-time data logging is required to enable efficient and self-automation through predictive maintenance type of use cases. So as you can see in the block diagram, this application uses several Infineon memory components such as NOR flash for program memory, fast async or hyper RAM for expansion, and NVRAM for the mission critical data logging. And as the complexity of the industrial control or automation increases due to increased IO control, maybe something like say automation decided to add more motors or adding more switches or conveyor belt or robotic arms, or even in fact adding more sensors to the system, they generate a lot of critical data and at extremely fast space. And that's where this kind of PLC demands extremely fast non-volatile write as a data logging memory. On top of it, these systems traditionally have used parallel interface memory, which accounts for a higher IO count. So what we are doing is now they are currently trending from parallel to high-speed serial interface to reduce the IO count, and the target is like something around 70 to 75% reduction in the IO count, which helps to shrink the size of the host controller system and board. And we are basically meeting or and providing these features through our Exelon Ultra family by offering a high-speed quad SPI in a very small form factor.
Yeah, industrial automation probably doesn't get the mainstream press coverage, certainly as something like autonomous driving, but that market is growing just very rapidly. And PLCs, for people who may not be familiar with those, the programmable logic controllers, they're a workhorse in the industrial automation and control. So you hit here on a number of the key topics that they care about right now, and that's edge processing, that's reliability, long lifetimes, and predictive maintenance are all super important in that industry.
Yes, that's correct.
In addition to automotive and industrial automation, you listed previously that medical was a key market for FRAM. So, what are the characteristics of your FRAM products that make them so well suited to medical applications?
Sure. So, in medical application, let's take an example of neuromodulator, neurostimulator type of, which are surgically implantable devices, and that use a very mild electrical stimulation to nerve system for pain relief and patient therapy. And these devices continuously record large amount of patient data and provide over-the-air diagnostics. So that is basically the use case for. And how does FRAM fit into it? Is FRAM is used primarily as a data logging memory, and it plays a very pivotal role in such system. Therefore, the reliability and data integrity becomes a significant demand or requirement for these kind of systems. Not only that, since most of these systems are surgically implanted, any maintenance activities such as replacing battery or system component had lead to basically surgical procedures at the cost of patients' discomfort as well as the huge medical bills. So what we have done, we have tried to address some of these issues by introducing the Exelon LP product, which has enabled extremely low power modes with highly optimized active current during the write and read operation. And these help to improve the system battery life significantly. And in some cases, we have seen the battery life improvement going over like 2x to 3x, which is great. And also, we have introduced a feature called the inrush current control, which is basically keeps the current under a specific limit such that if you are powering up the system, device does not drop beyond certain limit. And that helps a lot in a battery operated system where the battery is basically is not a very high current driving battery, and a small system basically they have a limited current source. And in this is this in inrush current control makes it a very friendly to that kind of system design. And on top of it, our GQFN package, which comes only in like less than 10 square footprint, makes it miniature enough to fit into a medical variable form factor, and also offer the required density for data logging purposes.
Yeah, that's an interesting feature you mentioned about the limiting the current draw because, yeah, as you said, these small batteries, they may have a pretty decent capacity, but their ability to provide instantaneous current, peak current, particularly on startup often, is really limited. And it's interesting, I find it almost humorous that a material called ferroelectric is immune to magnetic field effects.
Yeah, and that is correct. And also these systems are wearable on a human body all the time. So by if there is an like a susceptibility of any kind of radiation or say a magnetic field environment, probably that will restrict your movement. So by using FRAM, at least not only just power efficiency but also all this immunity related or the restriction also goes away.
Yeah, it's very exciting. For engineers then are interested in putting FRAM into their new products, so what types of design support does Infineon provide?
Sure. So as I shown through this the ecosystem or the design support, we not only develop the memory IC, but we also enable a strong ecosystem support by creating a whole product collateral, which could be app node, datasheet, knowledge based article, or Verilog model, which helps our customer a quick and error free design with Infineon parts. Okay, and also as an enablement of ecosystem, we also do have quite a few development kits which are available for you to start. For example, we do have a standalone FRAM kit which are designed with Arduino form factor, and any third-party controller kits with Arduino connector can hook up to FRAM Arduino kit and start work immediately. On top of it, we do have some MCUs kit with the Infineon MCU as well as FRAM or other Infineon RAM products on it. So these kits can be ordered via Infineon website. And if for more details, please log into www.infineon.com.
Yeah, so these dev kits are always a great way for designers and developers to test out new products. So it's nice to see that you've got multiple solutions there for them to get started.
Yeah. And not only that, we do have these components on other vendors kits. So like you can find them, you can find few of them are listed here. And to get more details, you have to go to the third party kits and basically download the details.
I really appreciate this introduction to FRAM memory and its applications. I remember first hearing about FRAM over a decade ago, so it's really exciting now to see it finally making major inroads in these demanding applications and markets.
Sure, and you are welcome to provide this platform to speak on this.
Excellent. Before we sign off, I want to encourage everyone to check out all the latest Infineon products on their Mouser Electronics manufacturing page. And a special thanks to FRAM technical expert Shavindra Singh for taking time out of his busy schedule to speak with us today on this Tech Chat, sponsored by Mouser.